All right. Onward into chapter 1 a little bit further. We're going to talk about section 3 now. The main focus of section 3 really has to do with the idea of ecological footprints. Ecological footprints are a way that we gauge what impact we're having on the environment. And so we're going to talk about those a little bit as we move forward here. So, first of all, a quick review for you. Some of these terms should be quite familiar to you, or you've seen them in some kind of context at some point in time in your educational career. The first one's the idea of a resource. So anything that we can get from the environment that we can utilize is basically a resource. We get so many things directly from our environment, like the sun, air, water, wind. Those are things that we can get directly right away. The other things take a little more process and a little more work to get, like iron, coal, crops. These are things that we still get. We still consider them resources, but they just don't come to us directly. And then when it comes to resources, there's really 3 different types of resources we can focus on. One, a perpetual resource. This is something that basically is continually supplied to the earth throughout a human's time here on the planet. The best example of a perpetual resource is solar energy. We just keep getting it. It just keeps coming in from the sun. It's kind of nice to have around. The other 2 terms that we've used in the past in all variations within your educational career in the area of science: renewable and non-renewable resources. In a nutshell, renewable resources are things that can be replenished rapidly. Usually when we define by rapidly, within a couple decades or within one human lifespan. If you can focus on that amount of time frame, you usually work your way with a renewable resource. Examples: forest, grasslands, fresh air, and soil are all examples of renewable resources. By contrast, non-renewable resources are something that either have a fixed amount or take a really, really, really long time to replenish themselves. Fossil fuels take a really, really, really long time to replenish themselves, and these 3 things at the end vary a little bit. So the first one is salt. Salt is something that, yes, it can fill itself back in with time. Usually, a seaway or something that gets dried up over time can replenish salt supplies. Copper and iron are things that are made inside of stars when they're created or in the process of dying. And so these 2 things are pretty much a fixed quantity on the planet. Hopefully they stay that way, because if not, it implies probably a supernova explosion or a dead star, which we don't want a lot of laying around. So we have these different resources, and when we're dealing with these resources, we want to handle them in a renewable way. And so this is where the idea of a sustainable yield comes in. A sustainable yield, a yield is when we take something out of a system. And so a yield is what we're going to get out from the environment. And when we do that, we want to focus on something that's sustainable, something that we can take out and not degrade that resource. And so sustainable yield is the highest possible rate that we can take stuff out without harming the resource. If we take more out than the resource can replenish itself or handle, then we get this next term down here, which is environmental degradation, where we actually shrink or hurt our overall supply of something, and the resource goes downhill from there. So if we want to avoid environmental degradation, 2 main ways we can do that are listed right here: recycling and reusing of things. We'll discuss these in much more detail as we progress, but these are ways that we can extend the life of a resource, or we can extend the life of a resource by reusing, taking something, putting it in a new form. Like this little guy right here is probably using these bottles for something more than what they originally was in the bottle. That's a reuse. Crush it up, change this glass into new bottles, into countertops, whatever we want, and we have recycling happening. So those terms are important as we move forward in understanding ways to lengthen the time it takes to use up a resource. I got a little excited there. Okay, so when we're talking about this idea of resources and things, it usually pertains to chunks of land or things that are owned by people, because people buy things because they are resources. They own things because they are resources. And it's a question of how we're going to go about using and managing those things. And so when it comes to these resources or rights, they are in the form of property rights or resource rights, and who owns them and who can utilize them. And there's actually basically three categories of ownership of these resources. One, it can be somebody's private property. It's owned by an individual or a company, and they have the right to use it however they want. Two, common property. This is owned by several different people, a group of people. It can be a small group or a large group. And then the last one is open access renewable resources. This is owned by no one, and it's available to whoever wants it, and it doesn't cost any money for them to utilize it. Now, the problem with these different kinds of properties is they all lead to different issues. But the biggest issue that we discuss in this class is a thing called the tragedy of the commons. Commons, you see the word common property up here. Commons can apply to either common properties or open access issues. And it's that old classic statement that you drive it like a rental. The idea that if you don't own something, people have a tendency to overuse it, exploit it, abuse it. And Tragedy of Commons deals with that specifically. So when we're talking about something that's owned by a large quantity of people, it's not really owned by anyone. Those things are the things that have a tendency to be degraded from a resource perspective the quickest. And so how do we manage that? What solutions exist for this tragedy that's happening? And the main solutions that you can have are really just two, okay? You can either solve the problem by creating more private ownership. So take whatever was public, say the national forest, and go ahead and turn that over into private ownership. Private people who own that resource have a tendency to take better care of it historically, and so that would help manage the resource a little bit better. The other way to manage it is with laws and policies. And this is not always fun for people, but it is why we have the Game and Fish, for instance, that maintain the laws and policies protecting our natural resources out there so that we can all enjoy them equally. It's about regulating how many people can get into national parks, and all of those things go with the laws and policies. And so we utilize both of these concepts from time to time for the United States, mainly when we have common properties, common things that we're sharing amongst the population as a whole. We try to regulate that using laws and policies. Now, when we're talking about these idea of resources and how much resource we use, a term was created, and that term kind of helps us to understand what kind of use we're undergoing. And that term that we want to know about is ecological footprint. It's an important term. It comes up quite often. Ecological, dealing with the environment. Footprint, how much am I as an individual, my country as a whole, how much supply, how many resources, how much land, how much water are we using up and taking away from? Where those limits lie? And so the idea of an ecological footprint is to give us an idea of that. And so if you look over here at the United States of any country has the highest per capita ecological footprint. We use more acreage of land than any other country per person. So if you look over here, there's a number, 9.7, which implies that for each person living in the United States, they need 9.7 hectares of land to live for a year on. And so you see that's considerably higher than any of the other options out there. Japan and the European Union are both close to one another, but they are less than half of what the United States uses. So we use resources in large quantities. Here's another way to look at the same idea, total ecological footprint when it comes to millions of hectares and shared with a global perspective. You see that those are our millions of hectares, that number right there. But if you want to look at it from an idea of percentage on the earth, the United States uses about 25% of the ecological resources available. So there's about 333 million people in the United States out of the 7 billion on the planet. That turns out to be 1/21st of the whole population of the United States. So it's a little over 5%. So the United States accounts for about 5% of the population, yet we use. All right, let's move forward here. Sorry, I got jumping around here a little bit. My computer's acting up. All right, sorry about that. So here's a basic idea of somebody in the United States versus somebody in India, the average American citizen, to give you a little perspective on how much stuff is used. So this is a picture of a family of 4 up here at the top of the page, and they're from Texas. So these guys are from Texas up here, and this picture is showing all of the stuff that a family of 4 in the United States has. So you can see there's large quantities of things. By contrast, the picture on the bottom down here shows a family of 4 in India. And you can see they have significantly less things. They're using far less resources than the people in the United States are. Here's the same quantity over here for the other countries. Japan's on top. You see they have large supplies of things, but not as much as the people in the United States, cars, larger homes, all those kind of things. And then when we look at third world countries, they have significantly less. And so the idea of who's consuming the most resources is something we have to keep in mind and understand so that we can best live a sustainable life. When we're talking about that, this idea of who is using most resources and that kind of stuff, there was an equation created, the IPAD. The IPAD is basically an equation that gives you an indication of what kind of environmental impact you're having. So there's several factors that work in determining that, but here's the equation right here, okay? So here's your equation for determining environmental impact. And so you'll see that there's 3 factors that come together to determine how much environmental impact you have. P, which is population. The population of any particular place has, the more population you have, the more environmental impact you have. The second one is the A. A stands for affluence. Affluence is basically per capita consumption. How much stuff is an average person using in that world? And the last is technology. With the use of technology comes the use of more resources to maintain that, from electricity to building supplies to all those kind of things. So 3 factors. Population, how much stuff people use, and how much technology they have, determines their overall environmental impact. And so this equation we'll use periodically throughout the class, but IPAD is the equation you want to keep in mind. That will end our discussion of section 3. I hope this helped clarify some things for you.